Light reaches the ocean only for a short distance. Below that, the environment changes completely. Color fades. Shapes lose meaning. Sight becomes unreliable. As depth increases, the rules that shape surface life stop working. Food becomes rare. Pressure never lets up. Movement slows. The animals that live here are not strange by choice. They are shaped by limits that remove most options. We have sent machines into space. We have mapped distant planets. But this environment, beneath our own water, remains mostly unseen. Only a small part has been observed directly. What lives deeper than that survives without light, without regular food, and mostly unseen. And the further down we go, the less familiar life becomes. Near the surface, sunlight still feels dependable. Shapes are clear. Distance can be judged. This feels normal to human eyes. It does not last. After a few hundred meters, light weakens. Red disappears first, then orange, then yellow. Blue remains the longest, but it is thin and fragile. Below this point, light is no longer expected. Life continues anyway. One fish that lives here is the lanternfish. It is small and lightly built. It does not rely on strength. Along its body are small points of light. These lights are produced by the fish itself. They are not meant to attract attention. From below, faint light from the surface can still be seen. The lanternfish matches this light. This makes its outline harder to detect. The cost is energy. Producing light uses fuel. Fuel is limited. The lanternfish cannot glow freely. Control matters. Scientists know how the light is made. They are still unsure how precisely it is used. Deeper down, another fish solves the same problem differently. The anglerfish does not try to hide its shape. Light is too rare for that to matter. Instead, it creates a signal. A small glowing organ extends from its head. It moves slowly in the dark. Food is rare at this depth. Chasing it wastes energy. The anglerfish waits, sometimes for days, sometimes longer. When something approaches the light, the fish reacts. The trade-off is patience. Most of the anglerfish's life is spent still. Speed is less important than timing. We have only observed this behavior a few times directly. Pressure increases as depth increases. Hard structures struggle here. Air-filled spaces collapse. Bones and shells become risky. Some fish avoid this problem by giving up firmness. The blobfish has a soft body with very little muscle. At depth, it holds its shape. The pressure outside and inside its body match. At the surface, this balance is lost. The body collapses. What looks weak above works below. The cost is movement. The blobfish cannot swim fast. It rests near the bottom and feeds on whatever passes close enough. Scientists do not know how far it moves or how often it feeds. Another fish uses a different solution. The viperfish lives in darker water. Food is even rarer. When it appears, size cannot matter. The viperfish has long teeth that do not fit inside its mouth. This allows it to grab and hold prey larger than itself. Its body is thin. Its muscles are small. Most of its structure supports its jaws. The cost is protection. The viperfish has little defense if it misses. It relies on surprise and darkness. A failed strike may mean a long wait. Sight changes again at this depth. The barrelly fish keeps its eyes, but they face upward. Its head is clear. This allows faint light from above to reach the eyes directly. This helps it detect shapes against the dark. The cost is narrow awareness. It sees poorly to the sides. It trades range for sensitivity. We understand how its eyes work. We do not fully understand how it moves through obstacles. As depth increases, time stretches. Many deep-sea fish grow slowly. Some take years to mature. Reproduction is rare. Missing a chance can mean waiting a long time. The gulper eel reflects this. Its mouth opens wide, much wider than its body. This allows it to swallow rare meals whole. The cost is energy. Opening such a large mouth takes effort. The eel cannot afford to do this often. It waits. We do not know how long it can survive between meals. Pressure continues to rise. Fish that live here avoid gas-filled spaces. Their bodies are filled with tissue that behaves like water. If you're still watching, you can subscribe for more of this. This prevents collapse. They do not resist pressure. They accept it. This removes other options. Speed is limited. Strength is low. Damage heals slowly. These fish are not built to escape quickly. They are built to last. Human observation remains brief. Cameras disturb behavior. Lights change outcomes. Noise spreads far. Some fish avoid our machines. Others may never approach them at all. This leaves gaps. We know these fish exist. We know some of their features. Most of their lives remain unseen. As depth increases, encounters become less frequent. Fish are spread far apart. Moving long distances costs energy. Energy is limited. Waiting becomes the safer choice. This creates another problem. Reproduction depends on meeting another of the same kind. In deep water, this is uncertain. Some fish release eggs or sperm into the water. Most of it drifts away. Very little succeeds. This wastes energy, but it does not require contact. Other fish take a more direct solution. In some species, a smaller body attaches permanently to a larger one. The smaller fish loses its ability to live on its own. It becomes dependent. This ensures reproduction when meetings are rare. The cost is permanent loss of independence. These solutions are not flexible. They exist because other options are gone. Movement continues to slow. Without frequent food, there is little reason to travel. Many deep-sea fish remain in the same area for long periods. Some move only when necessary. This reduces risk. Predators are rare, but they exist. Avoiding attention matters more than speed. Staying still uses less energy and draws less notice. Bodies reflect this again. Fins may be small, muscles are weak. Strength becomes less useful than endurance. Movement is brief and controlled. This is not failure, it is adjustment. Pressure never decreases. At great depth, the force is constant. There is no relief. Damage builds slowly over time. Healing is slow. Time allows this. Deep-sea fish often grow over many years. Changes happen gradually. The environment changes very little in return. Storms at the surface do not reach here. Seasons barely matter. The water remains cold and dark. Events are rare. This makes observation difficult. Human visits are short. Cameras record minutes or hours. Deep-sea life unfolds over years. Most behavior happens between observations. Scientists often see fragments, a single feeding event, a brief movement, a short flash of light. The rest is unknown. Some fish are known only from their shape. Their behavior is guessed. These guesses may be wrong. We do not know how often many species feed. We do not know how far they travel. We do not know how many exist. The deeper the water, the larger the gaps. Light appears again, but only briefly. Some fish use short flashes. Others glow faintly for seconds. The purpose is not always clear. A flash may attract prey. It may confuse a predator. It may signal another fish nearby. We have only seen some of these displays a few times. They may be common. They may be rare. We do not know yet. Pressure, darkness, and lack of food shape every feature. No body part exists without a reason. No adaptation comes without a cost. Better vision requires more energy. Faster movement increases hunger. Stronger bodies risk collapse. Every choice removes another option. This is why deep-sea fish often look unfamiliar. They are not shaped to be seen. They are shaped to survive conditions that remove most choices. Surface rules do not apply here. Surface time does not apply. A human life passes quickly in this environment. A fish may live its entire life without ever encountering another. It may feed only a few times. It may reproduce once. This is enough. The deep sea does not demand abundance. It demands persistence. Exploration remains limited. Only a small part of the deep ocean has been seen directly. Most images come from narrow paths lit briefly by artificial light. Large areas remain untouched, not hidden, not protected, simply distant. Technology improves slowly. Each visit reveals a small area. Each answer raises more questions. We still do not know how many fish live at extreme depths. We do not know how connected populations are. We do not know what forms remain unseen. Some environments may hold fish, unlike any we have observed. Others may not. Both remain possible. The deep sea does not respond to curiosity. It continues under pressure, in darkness, with little energy, at a slow pace. Most of it will remain unseen for a long time, and some of it may remain unseen entirely. Not because it is strange, but because it exists where human presence is brief, and understanding has not reached that far yet. For more videos about the deep ocean, you can subscribe. A like helps as well.